Okay, so again, these are basic considerations, and let me see what I can do here. Get those off to the side. All right. So make notes as we go through the PowerPoint, and if you have questions, we can come back to any of these. Okay. Well, when we're talking about Ohio, we're talking about a water-rich state, and you see the monthly precipitation there for Franklin County for a 30-year period. But we get our higher rainfall months in the spring and on into early summer. So we do get abundant rainfall. But what happens with a lot of that rainfall is we also have, if you look at the bottom right, we have a lot of evapotranspiration. We have a certain amount of water that gets infiltrated, but we also lose some of that water due to runoff and drainage. So one thing that we do, what we're doing with irrigation in Ohio is we use irrigation to supplement the water that the crop needs and to increase yield, to increase plant health and such. So it's a supplemental versus somewhere like in Utah or Arizona, where it's providing almost 90% of the water that's needed for crop growth. There's a number of basic considerations that I'm going to touch on. Probably won't spend as much time on equal time on all of these, but we'll do that. One thing I want to introduce to you, in case you haven't seen this, the idea of pressure or head. And when we talk about pressure or head, we can talk about PSI and pressure, and we can talk about head, which is an elevation difference with water. And if I've got a tank that's in the air 23.1 feet tall, and that's the depth of water or the height of water exerting pressure, and that would give us 10 PSI. And sometimes I talk to people and they want to know how much pressure they can get if they've got a tank 10 feet in the air, and that's going to be roughly 4 PSI. So we can get pressure out of having the water provide that hydraulic head. Okay, so that elevation, or we can talk in PSI, we can talk about elevation head. I won't do a lot with this, but I wanted to introduce this to you, and you'll have this in the PowerPoint. Water supply in Ohio, we've got a lot of very, very good aquifers, but we also have some landscapes, geology that are very poor in storing water. The image that you see there is Franklin County, and that's a groundwater, a summary of a groundwater resources map that ODNR Division of Water has done. And incidentally, you can go to their website and be able to pull up or order groundwater resources maps that are much more detailed and provide more information than what you see here. But this is just a summary. If you're talking about groundwater, we do have some problems with groundwater in certain locations, salt content and such, and just limited availability. We also have a lot of surface water in the state. Typically, we might have better water quality with groundwater, but with surface water, we could have pretty good availability, but it may have be more of a filtration problem. But they can be done, and a lot of people use surface water to do irrigation. We also have done some work with harvesting drainage water and runoff to provide water for irrigation. And I'll show you an example of that shortly. So if we're going to provide 1 inch of effective irrigation on 1 acre, we're going to need to have a water supply that provides 30,000 to 37,000 gallons. Okay, and that that effective irrigation is what is going to go into the soil that the plant can use. So sort of keep that in mind. Okay, water harvesting. This is a site in Fulton County where we've been harvesting drainage water for about 12 to 15 years to do sub-irrigation. I'm not going to talk much about that today, but we do we can use sub-irrigation to irrigate in some of the flatter landscapes where we have subsurface drainage. Drainage is very, very important. We've got a lot of varied landscapes, and we have a lot of soils that have very poor internal drainage in Ohio. And we can manage that internal drainage and the problems with excess water by using drainage, by managing the drainage and using subsurface drainage, and in some cases get adequate drainage relief with surface drainage. So it is an important factor. Okay, if we look at associated site characteristics, we need to have a better understanding of what's below the topsoil that we're usually working with. And so there can be very porous subsoils, there can be very dense subsoils, and in those cases you have a problem with retaining water possibly, and you may end up irrigating and the water goes down quickly in some cases, like on the top right, and you have other cases where the soil will allow the water to spread out and produce and be able to have more water available in the root zone for the plant. Okay, soil texture. The image to the right gives you a relative size difference between sand, silt, and clay, and these are the primary sizes of soil particles. We need to know a little bit about the soil. You can get really good information from your county soil survey, which is online now, and that was made available through NRCS and within our Division of Soil and Water Conservation. But knowing what the soil can hold will help us figure out how much we can apply and when to apply, and also how fast can we apply that water. If we've got a very tight surface soil, we can't apply the water very quickly. We may end up producing runoff. If we've got a very sandy soil, if we apply water too fast, we may end up applying more water than is being used by the plant. Okay, here again gives you a relative size difference between sand, silt, and clays, but it provides this textural triangle for you just so you have a resource to help you understand what the soil type is that you're working with if you have the amount of sand, silt, and clay available. You then can come in and then be able to determine its texture. And again, with the texture, if we've got a sandy soil, water's going to move faster, farther down in the profile. We have a loamy soil, which would be an optimum blend of sand, silt, and clay. We may be able to have a more uniform distribution of water for the plant roots. And if we've got a clay type of soil, we could end up with water being saturation in the top of the profile, and that's also not good for the plant. So texture does make a big difference, and we need to know what that is so we can apply that to the rate of application. Okay, soil structure is important, and we talked a little bit about that a few minutes ago. I've got a little bit of repeated information in here, but trying to emphasize what some of the terminology is. We have soil texture, and in a general sense, for each soil texture classification, we have a range of available water or the water holding capacity of that soil. And so even with coarse sand, we have some available water. When you go down and look at clay at the bottom of the table on the right, you can see what the relative difference is in inches of water available per foot of the soil profile. And you can look at some other textural classifications there. So give you an idea of what the soil can hold that is not going to be reduced by gravity. And that available water is what the plant can have access to and make use of. Okay, rooting zone. The image on the right is from the USDA Natural Resource Conservation Service Irrigation Handbook. By the way, you can download that from the NRCS web pages at the national level. But knowing what the potential rooting distribution is going to be and what the soil properties are in terms of the soil profile depths, we can match our irrigation strategy and timing and amounts to meet the needs of that plant better. If we've got a restrictive layer in the profile, then the rooting systems are not going to expand the way some of these are illustrated. Evapotranspiration, basically how much water that the plant transpires to the atmosphere, as well as evaporation from the soil surface or leaf structure, leaf surfaces. The corn and soybeans, we have a lot of information on corn and soybeans about critical stages in the growth stage of these plants, so that we know the optimal times that we need to be irrigating. And in Ohio, with the water resource, the rainfall that we have, I don't know what's going on here. We know if we've got a limited amount of water and we want to irrigate either of these two crops, we can save that water for those optimum times where we really need it. And that's going to be largely the reproductive stage that's illustrated in these two illustrations here on the right side. We figure from a design standpoint that the average evapotranspiration or the potential evapotranspiration rate for purposes of design, we on a daily basis in our type of climate, which I would call moderate to warm, 0.25 inches per day is what the plant will use or could use. We might use that as our design rate and to design how fast, the type of system, but also how fast and how much water we're going to be applying. Okay, something that I want you to understand is different classifications of water. And if we go look at a oven dry soil to a permanent wilting point, we call that's water unavailable to the plant, but we call that hygroscopic water. We're getting a little bit technical here. If we go from wilting point to fill capacity, then that is the water that is available in the soil profile for the plant to use. We call that capillary water. And then whatever drains out if we're at saturation and we have drainage water, that's water that the plant cannot use or typically will not use. And if we're at saturation, the plant typically is not going to be using very much water. So what we'd like to do with irrigation is stay in the range of fill capacity to wilting point, permanent wilting point, but somewhere in that range. And that's where we want to try to keep the water volume, the water bank at some point, at some percentage of that available water for plant growth. Excuse me. Now on the page following this, there's a summary of what I just went through in a little bit more detail for you. Excuse me, just a minute. Okay. Other considerations, I'm going to walk through a number of these. And one thing, as we get down through here, the fact sheet that Cassandra is going to provide for you is a draft fact sheet, and it's got a little bit in there about management. But one important thing about management is that irrigation is not a substitute for poor management. And if you're going to do irrigation, you need to be able to manage the irrigation and the timing of your irrigation. If you work with a consultant who designs the irrigation system for you, that person should also be able to provide an irrigation plan and a schedule. And that schedule can change depending on the amount of rainfall we get. But those are good things that a good irrigation designer will provide for you. One thing that I've always talked about, and I think most people who do work with irrigation will say, if you wait until you see stress, crop stress, and as you walk the field, and then you start irrigating, you've lost time. You've gone past the optimal time to provide irrigation to your plants. So keep that. We don't want to use the signs of crop stress as a signal of when we do irrigation scheduling or start to apply the water. And that's why having a better understanding of how much water is in the soil based on its texture, and so that you know on a daily basis, if you're using a 1/4 inch of water or estimating that, you end up with, can count the number of days and using the available water holding capacity of the soil to see when you might need to start irrigating. If you want to know a little bit more about irrigation scheduling after this, you can contact me through my email and I'll provide some more information there. Okay, getting a good designer. We've got a limited number of people in the state who do design work and provide equipment or irrigation materials. I work with Columbus Irrigation and have for the 32 years I've been at Ohio State. I forgot the guy's name now, but he's up in Ashland, I believe. And then also Mark Ackerman, or the Ackerman site is up in Fulton County, Ohio. I think there's Zimmerman's out of Pennsylvania that does some work in Ohio. And there's also someone over in the Deer Creek area. So those are the ones that I'm familiar with. What that person can do is come up with looking at what your resources are, or at least be able to try to match your resources with your irrigation need. We don't see a lot of people, or don't suggest that you look at your neighbor's situation and say, well, that's what I need in my situation. You need to engineer your entire system and tailor it to the specific situation that you have and not someone else's. I think you will find a number of consulting engineers and other technically minded people who can perform a nice irrigation design, particularly when you get into drip and trickle. Other considerations that are important, filtration. Like I mentioned earlier, if you're using surface water as your water supply, you're going to absolutely need to filter that water. And I have found that it's also best to use filtration when you're using well water. The work we've done at the Waterman Lab on Kinney Road, just off campus, we've ended up almost always using a little simple filters when we do trickle and drip irrigation. At the end of the fact sheet, I provided an information inventory. It doesn't have, I'm not going to provide it here, but you can, Cassandra will offer or provide that fact sheet for you. And that inventory sheet at the very end is a good thing to help you note and determine what information may be needed by the irrigation designer to design a good system for you. But basically, soils and geology information, geologic, what the topography is, and you have challenges when you start to have more rolling and sloping landscapes. Precipitation, that's going to be pretty much stable for your county, if your location, in terms of what you might expect. Your water supply sources, power source, crops that you're going to be working with, your farm operation schedule, your financial resources. But there's a whole list of things there to go through on your information inventory. And that would be information that you would want to pull together before you call in a designer to work with you. Let's talk a little bit about the different systems. We still have people using large-scale overhead irrigation systems that may provide this type of picture. This is actually out in Nebraska, I believe, but probably a good percentage of that water is going to go into the air. It'll be evaporated, and so the type of system that you end up with will have some loss of water. Now, almost every type of irrigation system will have a loss of water, and that then relates to the efficiency of the system. So irrigation that pumps a lot of water, but sprays a lot of water out into the atmosphere, local atmosphere, you're going to be losing probably 20 and sometimes 30% of that water, depending on the air temperature and the wind. For overhead, for sprinkler irrigation systems and micro irrigation systems, got this table that comes out of a publication that's listed below about the types of sprinkler systems, which would be overhead and largely, and micro irrigation systems. So you can see some of the relative differences between these two systems. We've seen a large increase in overhead irrigation systems in most of our river valleys in the southern part of the state. And we also have some locations in Northwest Ohio and Northeast Ohio where people are using overhead irrigation for basic irrigation needs, but also in Northeast Ohio with the application of liquid manure, using that as a water source. So this just gives you some general information, general facts about these two, give you these two types of irrigation systems in general. And so it can kind of give you an idea what's possible. We have an awful lot of high value crop irrigation in the state that are using micro irrigation and largely using drip tape, and in a lot of cases with high production, vegetable production rather, using irrigation under plastic in rows. And I've got a picture to show you about that here in a minute. Okay.
Quick question.
Yes.
Is it possible to use like either surface or rain, some kind of a rain catch system? How much filtration would be needed to use that for, especially a micro irrigation system or a drip system? Is that even possible?
Yes. Well, I lost the first part of what you said, Cassandra. I'm sorry.
If you're using a rain catch system for an irrigation water source,
yes,
can you do enough filtration to use that for some of these smaller, finer
yes,
parts?
Yes, and there are some very simple filters and there are some more expensive filters, and I've got some examples of that at the end that I'll show you. The one that I use on small scale drip irrigation systems like out at Waterman and some community gardens in around the Columbus area, a very simple filter, and they have to be clean, but I'll talk a little bit about that. A good question. One thing that if you're capturing water off of roofs, you've got to realize that you've got some grit that's coming off of the roof, depending on the type of roofing material you have, and you've got maybe some animal deposits up there, bird deposits and such, raccoons maybe. So it does need to be filtered. And I don't think there's any water supply that I've worked with in the state where I would not use some sort of a filter, maybe a simple filter of some sort at minimum. Okay, I'm going to move on past this, but in overhead irrigation systems, there's been quite an advance over the last 20 years, providing more adequate distribution of water, but also limiting the amount of evaporation. And so putting the water application down in and closer to the canopy rather than spraying it up into the air reduces some of the water losses that we have. And you can see a number of these, you can see systems like this in different places in Ohio. This is in Southern Ohio, and this is basically a linear move system for, one of them is up at Union County and the other one is in, I think, Pickaway County. Both of them are turf applications, and but you can see with the sprinkler in the bottom image at the top of the boom, and this is an older system, but it's still a very good system. But this is for a little bit more large scale operation. We have a number of these gun systems. I think Ackerman's sells quite a few of these, and they can apply a lot of water fast, and they will move through the field under their own as the way that you set them up so that you don't have to be out there, but they'll shut off when they reach the reel. And so they do have an application. Okay, again, some little bit more comparison information about the sprinkler irrigation equipment, of the types of systems and relative costs, because the costs can change from year to year and through the years. But this provides you kind of a relative investment cost difference, relative labor cost difference, and the practical hours of operation per day. So if you're going to be looking at some larger scale systems. Drip and trickle. Man, there's a lot of application of drip, trickle, and micro irrigation around the state. So I think if you go to Farm Science Review, you'll see a lot of applications there. If you go to any container nursery production system, you'll see a lot of types of irrigation there. And these are very common. They're relatively simple to put together, and worked with a number of master gardener groups around the middle part of the state and community gardens to put in these types of systems. So they're very easy to teach people how to use, and really recommend these for small scale production. All kinds of applications depending on the way you're growing the plants, if they're buried in, if you're in the soil, if they're plant materials, they're crops, in pots, or whatever that could be. Just a lot of ways to apply this technique to doing sub-irrigation. There's been some movement out west with looking at putting the drip tape in the on the surface and also below surface. So subsurface drip irrigation is more popular out west, but we do have a couple of farms in Ohio that are using subsurface drip irrigation on small acreages of corn. Okay, this is what the drip tape looks like. Where the knife is, that's a slit. That is the little slit where there's a little nozzle in there, and that lets water drip out at a drip, 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 drip rate. These are designed so that they minimize the amount of clogging. So the illustration at the top left gives you, kind of illustrates what's going on, and trying to prevent these nozzles from being plugged. The bottom left, that's actually a location in South Africa that I put in an irrigation system for a local community. But I did this to demonstrate to them what would work, how this irrigation would work. And so this is a surface irrigation technique here, but very easy to install. It's durable enough that you could pull this up if you didn't have somebody hoe into it and use it again for several years. And the Master Gardener group at Waterman has been doing this. They have a stash of tubing, and they are able to use it year after year for a limited number of years. Putting the drip tape under plastic is done routinely in the vegetable production area and all over the state. And the plastic helps to minimize evaporation, but also to help control weeds. So beds like the one you see, these that you see here, and we have some of this type of activity or production out at Waterman Lab on campus. Just the machinery that's used to put the plastic down, and you also can put the drip tape in while you're providing or putting the plastic down. Okay, now we got surface versus subsurface. Surface irrigation, drip irrigation on the left, and subsurface drip irrigation on the right. One thing with the subsurface drip, you don't know for sure what the distribution is, and you need to sometimes check and see. But on the surface irrigation, if you're not under plastic, you can see where the water, how it's spreading out over the soil surface. Just another illustration of subsurface versus surface drip irrigation, sprinkler irrigation, those types of things. So it gives you an idea how that water can be distributed. I'm going to go ahead and pass up the subsurface. Okay, and I'll pass up to this one. Now, you can go to any irrigation company, manufacturer websites, and you'll find a lot of good illustrations of all the components that may be involved with putting in a typical drip system. And you see this is a nice illustration here. Of course, Toro is marketing their own type of tape, which is the Aquatrax drip tape. And I've used a number of different products and they all work well. They all have the same problems. They all have the same benefits. Maybe some of maybe at this point with the advancement in the technology, there's not a whole lot of difference between these. But you find a good salesman, you find a good sales rep who can guide you into making the proper decision. This was put in, I believe, I forgot what county, but I did this so that people could see how to set up a control station. And with this system, we were irrigating 3 zones, and we could irrigate all at once, or we could irrigate each zone independently. And that's what the 3 valves are on the left-hand side of this illustration. Putting in pressure gauges, simple pressure gauges, so you know what the pressure is as the water moves through different parts of this system. We've got a flow controller involved with this. See, there's a water meter on the right-hand side, but you notice there after the first pressure gauge, between the first and second, you see a little filter, and that's just a small scale filter, probably costs 30 or 40 bucks. We can plumb that in, and the little orange knob there, while the system is operating, I can turn that knob and backwash the screen filter that's in that. And so that's a very economical way to filter the water. Okay. All right, water quality problems. If you've got hydrogen sulfide, high sulfur content in your groundwater, you're going to need to do something probably to take care of that. Iron, bacteria, water hardness, sediment getting in. So you got a lot of things that you need to deal with, possibly deal with, where you can be able to decide if you're going to need a filter and what size and type of filter you would need. But my recommendation is, even if you're using tying into your home spigot, outdoor spigot, use use filtration and use these simple filters. Okay, on the top right, you can see the spin filter and components, very simple. That's a stainless steel screen mesh that goes in, and the water, when it first comes in, it comes into that filter, goes through the screen mesh, and then goes on its way to irrigate to the irrigation application. In this case, when you fit all these things together, you can actually, while it's running, turn the little nozzle on it, the little blue bulb, and be able to backwash that screen filter. So you don't have to stop it and take it apart. There are a number of very simple, much cheaper inline filters, but you have to stop the system and disconnect to be able to do the backwash. The bottom right is about a $30 or $40,000 filter system. It was at the Piketon Research and Extension Center in Pike County about 20 years ago. And then on the left, you see it's a disc filter. It's a much larger filter, and it's going to be more costly. I don't have up-to-date prices on that type of filter, but we have plumbed those in some of our demonstration sites. Okay, maybe I got through a little bit quicker than I thought I would, but provide a little bit more time for questions then.
We've got one on the chat that I'll go ahead and throw at you. Julia is wondering if there is some research going on biofilms for drip tape or any kind of alternatives to plastic. So I know there's some work being done by Katrina Cornish, but I don't think anything that applies to irrigation. But Larry, do you know of some things?
Bio.
Would that be a concern because of the water would break it down? I don't know.
Well, you're talking about for biofilms to actually affect the distribution of water.
Yeah, so like instead of plastic on the irrigation tape, are there some alternative products that are maybe a little more sustainable?
No, not really. There are a couple of people in Africa and India that are working with something that, in terms of a better way to apply the water with limited water supplies. But no, I don't know of anything that's even in that area that people are working with. The tape, using the plastic, is a problem in terms of what are you going to do with it after you use it. There are companies in the southern U.S., Alabama, Mississippi, and elsewhere where companies will come in and get all of that tape, and it's polyethylene, and then they can recycle that material, and that's being done. I haven't heard of anybody being able to do that in Ohio or Indiana. And what typically happens if they pull the tape up, which they do, say if you've got 30 acres and you've got it in beds, you pull the tape up at the end of the season, they either take it and burn it or they take it and bury it. And, they just haven't gotten to the point where people will think about recycling that material, and it can be recycled. It's polyethylene, and it's good quality polyethylene. Okay.
There was a push to try to recycle some of that material in the nursery industry a couple years ago, but that was like back in the 90s, and Rumpke was working with that, but I have not heard anything about that lately. So
yep. I know that I found out that if I put drip tape that I've pulled up out at Waterman, if I take that and put it in my plastic recycling that Rumpke picks up, I found out that they end up, maybe, I don't want to mention Rumpke, whoever picks that up, that it doesn't get recycled. But it is a good quality polyethylene that could be recyclable if you had enough of it.
Yeah, I think it's a real problem for the organic industry because, they want to do right, but, if you're using plastic as a mulch product, it's a real problem.
Yeah. Yep.
So good question from Julia. If there's some other questions out there, feel free to unmute and ask away. Julia also asked a question about pump recommendations. So I don't know if that's in the handout. I didn't look at it very carefully, but I did put that handout up in the chat, and also it'll be on the website where the recording is. So can you address pumps and selecting pumps a little bit?
Yes. There's a pump manufacturer up in Mansfield that I used to work with some years ago. And in terms of estimating what size and capacity of a pump you need, there are some textbook types of things where it can help you figure that out. What I recommend is that you get whoever is going to be you're working with on your irrigation materials, they will be able to provide that for you and give you an estimate that'll fit your specific needs. You can, if you know what your hydraulic head is or your pressure requirements, you know what your volume is or the capacity you need, you can go to a number of places that sell pumps and see if they have a pump that'll match your needs. So it's not something that's rocket science for small scale production, but I would recommend you going to, if you're working with an irrigation equipment or a material supplier, get them to help you match the pump for your particular needs. And if you know, if the designer knows how much capacity you're going to need and knows what kind of pressure requirements you have and how much energy you need to be able to provide with that pump, they can match things up very, very well. You can get pumps. I'm trying to think of the company I work with here in Columbus, but they do have some small scale pumps, and they're in the $200 to $500 range, so it's not going to be, well, it depends on what you're growing and what your profitability can be when you're using irrigation. So again, come back and go to your supplier and have them help you figure what your pump requirements would be. I'm trying to think of the Columbus irrigation guys up in Ashland, and then Mark Ackerman, the Ackerman group that's up in Fulton County, and other suppliers can do this for you. If you were to get online and do a search for sizing a pump or how to select a pump for irrigation, small scale irrigation, a number of universities have fact sheets that will walk you through how that's done and what to look for. So there's a lot of resources online, but going with a land grant university in any of the states, if they have that material. So.
Do you recommend maybe working with someone local so that would they be more familiar with the kinds of soils in the area and concerns, or is that going to vary so much from farm to farm that it doesn't matter?
Well, what they'll do, like the Columbus irrigation guy, I've worked with him. I have bought materials from him that I use for the master gardeners, but he's got a pretty good idea. He's worked with the fruit and vegetable production folks for a number of years, and but you can find out information on a particular site using the soil survey, and then but also taking some samples and to see what the topsoil depth is, to see what some of the subsoil characteristics are, and that can be done on site. But what probably is critically important is that A horizon, if you're using drip trickle, is not putting the water on too fast, depending on if it's a more clay surface soil versus a sandier surface soil versus like a silt loam or good loamy soil. Dan Burkhoff, I think is what his name is. He knows that stuff. Mark Ackerman up at Ackerman's would be the same. I don't happen to know personally the other people, but they do understand soils and they will match what you're trying to do to your soil, and they'll match their design to your soil conditions and landscape topography conditions.
One of our attendees is asking, do you have a simple schematic for micro irrigation?
Well, let's see. Putting this one back up. And also, this just shows the main elements, but you'll have for micro irrigation, what you see in this illustration, and people can download, eventually you'll be able to have this PowerPoint as a PDF that they can download. Where you see on the right-hand side, the lateral and emitters. The lateral would be the drip tape. The emitters would be individual locations where water comes out. But the sub-main line and the main line, those are going to be polyethylene plastic, or and so you would end up having these mains and sub-mains that provide the water to those laterals, to the laterals where you're using drip tape. The Master Gardener group that's at Waterman, and if you find other Master Gardener groups in your county, there may be, if they have irrigation, they're most likely they're using most of them will be using some sort of drip tape. And the ones that I helped last summer or the year before at Waterman, we put in a really nice, very simple system, which basically looked a lot, the components looked a lot like this setup we have here. And so the pieces just plug into each other. There's just a lot of parts and pieces, small, where you can fit something, whatever kind of landscape and whatever kind of soil that you have. There are handbooks. If you were to get online and look drip and trickle, drip tape, trickle tape, and do a search, you'll end up finding about 6 or 7 or 8 different companies that sell the tape. Every one of those companies has a handout or has a little manual on how to design the system yourself, or guidance on that. So there's a lot of good resources online now, and they weren't there so much, 10, 20, 30 years ago. So are a lot of good design resources. One thing just to mention real quick on this illustration at the bottom, it says backflow preventer. So that is a must, and I didn't provide a picture of any of those, but it's a very, very simple little device that you plumb in. And that's in case there's a power outage or surge, you don't want water going backwards and then contaminating your water supply. And I use those. I recommend those for household systems or any type of system. But they're probably about a $2 or $3 item for small scale irrigation or drip trickle irrigation that can be plumbed into the system.
Sandra, feel free to jump in here if I'm not getting your question right, but the filter goes before the flow regulator on this?
In this particular case, let's see, the flow regulator. It can, I'm trying to see if there is one in here. In this particular, there is image isn't, but let me go to the previous one. In this image, you see the water meter there coming from the right-hand side. That's the inflow coming from the pump. And then you've got the first pressure gauge, you've got the filter, then the second pressure gauge, and then got the flow regulator. And that just provides, if you've got enough pressure, that provides a reduction in the pressure. So if we're using drip tape, we don't want to have pressure so high that it will burst the tape. And we're usually operating these at I'm sorry about this. We usually operate drip tape between 8 and up to 15 PSI. So it's a very low pressure type of system. Low pressure, low volume. And in this particular case, I have taken the filters in there before the pressure reducer that's controlling the amount of water that's going in the pressure to the drip tape. And so it can be done either way. If I back up to the previous slide, yeah, I guess, not sure the valve there is a pressure reducer. That's not, I don't have one of those listed, shown in this particular illustration. But ultimately what I like to see is that the filter, having the filter closer to where the water comes onto the site, the better. But it doesn't always have to be that way. So it can go either way, really. And you notice this has got a secondary filter in it. And I've never used a secondary filter in the systems that I've worked with. This may be an older illustration.
Thanks, Larry. Another question from the chat. How do we get irrigation uniformity value for each wait, I'm saying this wrong. He's asking about irrigation uniformity value for each type of system available. How do you measure that value, targeting 85 or better?
Well, there's testing done of all these drip tape products. And there's a institute out in, I think, in California that actually conducts a lot of the research that will give you the uniformity. And we're talking about uniformity, we're talking about the distribution of water coming out of a whole series of emitters. And we would like each emitter to be able to provide the same amount of water at the same rate and provide the same application of water. So if you have 100 feet of drip tape and you've got the proper pressure and water supply, then you would want that distribution. We want every one of those emitters on level ground to provide the same amount of water. That's what uniformity would be. You have uniformity that would be published information about how well the whole, the difference in, or the limited difference or the minimal difference between emitters and applying the water. But then in the real world out in the field, you know, you're hopefully on level ground, you want each of those emitters providing the same amount of water. If I'm understanding your question right there, Cassandra.
Not my question. So hopefully I've translated it right. And to the person who posted that, if you want to unmute and clarify, that would be fine with me.
Let me go back here for something. With this drip tape and the bottom left illustration, this on this particular soil with this drip tape, and you notice when the drip tape is pressurized, and we're running at about 8 to 10 psi here, it's a circular tube when it's pressurized. But you look at each of these circles, and these circles are providing show that what the distribution of water, and so that to me is what the uniformity is. And if you have a sandy material and you've got those, well, let's go back to uniformity, providing the same amount of water at every one of those emitters along that length. So if you've got a 200-foot run and you've got to have enough volume of water being applied, and if you're on flat ground, you would want every one of those emitters applying the same amount or dripping the same amount of water. And so that's uniformity. Now, if whoever asked the question, if that's, you can let me know if that's you know, answering the question that you have. Rarely get uniformity questions, but it sounds like somebody's had some experience with drip or trickle.
One more question here from the chat. What about irrigation timers? And they're talking particularly for seedling production. Any recommendations of some brands that are better than others? And it looks like they're using that probably with overhead sprinklers. That helps.
Well, I haven't used timers. What people use them. The Master Gardener group out at Waterman, I think, may have used them, but I like to have when I'm working with a Master Gardener group or community garden, have them have hands-on until they really understand the use of the system. But timers do have their place. If you fully understand how long you really need to run the water based on how well the uniformity is, and you're not wasting water, timers they do have a place. And I haven't used timers, so I can't provide any recommendations there. One thing that I did observe one time out at Waterman, that they had just transplanted cabbages, I believe, and they had a riser system of overhead sprinklers, and they turned it on and they walked off and we ended up with a nice drainage event. They just ran way too long, so they walked off and left it, and somebody forgot to come back. So timers definitely have a place, but make sure you understand how your system applies water, how fast you see the water moving out into the profile. And so having some good knowledge about what's going on when you do the irrigation can help you make a good decision about whether you need to have a timer or not. If you've got a lot of sites, the timers can be very useful. Now, you said seedling production.
Yes.
I'll tell you, someone you might talk to about timers for that, if it's in a greenhouse situation or a very concentrated production system for part of the production system. Peter Lean, he's in our department up at Worcester. He may have had some experience, much more experience with timers, and he works with the greenhouse industry and greenhouse irrigation and fertigation and things like that. So he might be a good resource for. Say that again. Is that Brian?
I'm not sure if that was a question or maybe somebody hit unmute by accident.
Okay. I see.
Accident, sorry.
Okay, that's it.
Is that Brian Gwynn from Worcester?
Yeah. I think he was the guilty party.
Okay. All right. No problem. No problem.
Any other questions from anyone? We're kind of we're over time already, but I hopefully everyone's enjoyed this and gotten some useful information from it. The handout and the slides are both posted in the chat, and they'll also be on the site for the seminar series, which is go.osu.edu organic series. So you can check that out. I will also try to have the video posted hopefully by tomorrow, depending on how fast it comes back to me here.
Cassandra, if I also could ask, if you do anyone gets a chance to read through that draft fact sheet, I want to make some major revisions in that, but if there's anything you don't understand in the explanation, just shoot me an email, and I would really appreciate any comments from people out in the real world. They're very valuable comments.
Agreed. All right, and I just put Larry's email address in the chat. Brown 57, right?
No, 59.
Oh, I'm sorry, what, 59?
Yes.
Sorry about that. Let me fix that.
Okay.
I remembered it, but I'm a lot of us Browns in the system. I'm 1,844, so 2021. There we go. All right, thank you everyone for joining us, and we'll be back next week with a talk about various nightmare weeds and how to control those using cultural methods. And we'll have Matt Kleinhenson a little later next month to talk about high tunnel production and considerations for organic growers there. So we will take a break during the OFA conference. If you're going, we should have a booth there. So look us up and say hi. Thanks everyone again, and thank you very much for presenting today, Larry. Appreciate it.
I'm glad to do it. Thank you.
Thank you. Hope to see many of you next week.
All right, Cassandra, thank you very much, and good luck with your career.
Such as it is.
Yeah.